Okay, today we're going to talk about the replication part 3, the system design. Okay, first of all, we're going to talk about the replication architecture to design the system using replication. When designing replication, there are two things that need to be considered. The first one is the replication types. Okay, um, the first one is the replication types, and the second one is the formation types. Okay, the replication type, it literally means how the data will be replicated. Okay, Altibase replication provide two different methods: the lazy and the eager. The lazy method replicates the data in asynchronous way. Okay, and because it is replicating in an asynchronous way, the master transaction is not affected. So the fast data replication and the fast processing of master transaction is available. The eager type uh, replicate data in a synchronous way, okay, and because it replicates data in similar types as two-phase commit, so the performance is slower than lazy, but it can guarantee high data consistency between replication nodes. When configuring replication, the performance or the data consistency can be improved depending on the replication type chosen by user. Okay, so the appropriate type for the system has to be chosen. Okay. The replication type can be changed later. The replication type is firstly assigned when creating replication object. So in order to change the replication type, you can just create another replication objects. Okay. For the formation type, the user has to choose the formation types as well. Using replication means using two or more databases. Okay. Therefore, in each database in replication has to have a role. For example, the DB that does modification task is assigned as active server, and the one that doesn't is assigned as standby server. Once the active server is assigned, you can start the replication by starting the replication objects. Okay, for example, when managing two databases in active environment, okay, you can just start all the replication object using alter syntax from two different nodes. Okay, starting replication means also activating the sender thread as well. Okay, therefore, when start is executed on both nodes, then both sender threads are also activated and they become active environment. So what do we have to do in order to configure active standby environment? Only the sender from node A needs to be activated and started, and the standby node does not start. Okay, then it becomes the active standby environment. However, when considering failover even from active standby environment, then it is better to start from both nodes. Okay, in order to replicate data, after replication object is created, the replication must have started, meaning the replication start command must have been started before replicating upcoming modified data. Okay, let's think of another example. To form active standby, the start was not executed on standby node, but all of a sudden the active node got failure, meaning the service became unavailable. So it fell over to standby node, and any data that is modified from standby node is not replicated to active node, and even though the active uh, node is fully recovered. Okay, so when considering failover even from active standby, it is better to execute start from standby node as well. So even though the start is executed from standby node, no need to worry about the conflict because the user already know it is standby node, so there will be no modification from that node unless it is failover. Okay, if you're thinking of active standby just for backup server only, not failover, then standby node can be used without start. Okay. Okay, let's talk about the synchronization point between replication nodes depending on replication types. I think there are two types of replication in Altibase. There are lazy and eager. Okay, lazy and eager. Um, the lazy and eager and the synchronization point of replication node is different depending on the replication types. Okay, in lazy type, the master transaction and replication transactions are executed individually, so that there could be a data gap from the same point between the nodes. As you can see from the figure 1, the inactive node, the transaction finished executing and the data is reflected, but in standby node, it may not be reflected as the X logs are arrived or still processing them. Therefore, for the lazy type, the transaction speed is fast, but you must think that the data gap is occurred from the same point. In eager type, the master transaction and replication transaction operated as one, so there's no data gap between nodes. The transaction finished executing from active node when data from modified from active node is reflected to standby node as well. Therefore, both nodes have to have same data. And it has to wait until the transaction executed from active node is fully reflected to standby node and finish, so the performance is slower than lazy. So because um, the eager type is where master transaction and replication transactions are combined together, we say all or nothing. Therefore, the gap occur while using replication is due to replication type, not the formation type. When the lazy type is used, the gap is absolutely normal case. However, if the gap is increased continuously, then it could lead to serious problem. Therefore, the alternative must be found to prevent such cases. Okay. Let's talk about the replication type that we have talked about before. I said in lazy type, the master transaction and replication transactions are executed individually. So when you look at the diagram, the transaction is executed from local server. Okay. Suppose that this picture is standalone and not the replication. Then there will be no problem even though the transaction finished executing from the local server only and finish writing into reader log. So also in lazy type, when there's no problem even though the transaction finished from the local server only, which is only up to number 2. Okay, number 2 is called master transaction. And where sender thread creates the xlog and reflects the content into remote server is called replication transaction. Okay, and these two transactions are handled separately. So the master transaction does not wait until it is fully reflected to remote server and finish executing once it is reflected in local server only. Okay. So the performance is fast, but there could be a data gap because there's just some delay when data from local server is reflected to remote server. That's why it needs to be considered when using lazy time. The eager type is processed as one transaction which is from 1 to 7. Okay, 1 to 7. One transaction means if either one of them fails out of this 7 tasks, then the entire transaction is failed. Therefore, the transaction executed from local server finish when it's fully reflected to remote server. Therefore, there's no data gap between two nodes, but it has to wait for transaction to finish, so the performance is slow. Okay, just to add another information, before sender thread sends the xlog, the sender thread writes the information of xlog into meta tables. Okay, this meta tables. And also when receiver thread from the remote server they receive the xlog, it writes the xlog information to the meta tables. Okay, first before sending to the storage manager. Okay, I mentioned about replication gap when I was explaining about replication types. The gap it literally means the data inconsistency between nodes. The data gap between nodes can be checked through the performance view table called read gap. Okay, read gap is replication gap. But when we talk about replication gap in a database, the gap is not a difference of data size of number of records. The house replication gap is expressed as I said the replication is something where the sender thread reads the reader log and converts into xlog and sends it. Okay, and when we dump the reader log, we can check the sequence number called LSN. Okay, LSN inside. The sequence is recorded in every log, so when the sender thread reads the log, we can check how many logs that the sender thread is up to. So that means the sequence number is also recorded in xlog, and we can check how many xlogs that the sender thread has sent so far, and also how many xlogs the receiver has received so far. So when we talk about replication gap, it is a difference of sequence number. So the replication gap is equal to most recent LSN. Okay, I'm the made from local server SN. Okay, minus the sequence number of most recent log x that most recent x log that is sent, the restart SN. Okay, the replication gap can be occurred during application is operating, but this is because the replication type is chosen as lazy type. The lazy type can improve the performance, but on the other hand, it can cause the replication gap. Okay, the replication gap is not a big issue because as the time is passed, the synchronization is processed. However, if the replication gap is continuously increased or remain, then the conflict will occur. Then it might lead to serious problem. Therefore, the solution is needed to optimize the network performance so that the gap is reduced by quickly sending the XLR. And let's say there's a particular service where the gap is never allowed, then the eager type can be chosen rather than lazy. Okay, the replication, the formation type can be chosen out of two types: the inactive, active. Okay, inactive, active. The modification is available in every replication nodes. Like Figure 1, the modification is available from every single node. Therefore, the performance and scalability improvement through load balancing is available. However, because the modification is performed every node, when a modification of same data is executed at the same time, the conflict can be occur. So we need to take care of that too. In active standby, like figure number 2, the modification is performed only from the particular replication node, and in rest of the nodes, the modification is not allowed. In active standby, the conflict is not occur as there is a limited number of nodes that can modify. However, there's also limitation of load balancing and scalability. Okay, for active standby, the standby node can be used not only for backup but also for select statement only. Therefore, the load balancing is partially available. The performance improvement through load balancing is available depending on which formation type is used. You need to be careful as the conflict could occur when modifying. Okay, also, the consideration differs depending on the formation types. When it's active, the log competition could occur. Okay, because DMLs are executed on both sides, so the log competition has to be minimized when writing application program. In active standby, there's a assigned node that can modify. Okay, therefore the style of writing application can differ depending on the role of each node. Meaning, for modifying application on active node and application for select only on standby node. So in active standby, there's a complexity writing different styles of application for active node, standby node separately. Okay. Now we're gonna have a look at now we're gonna see the how to configure the system. Okay, like a diagram 1. When it's active, the number of replication objects have to be created in each server is equal to the entire number of nodes minus 1. Okay, and once they are created, it must start all the replication objects. Okay, so it is minus 1. In active standby, you have to create a replication object as the number of entire server minus 1, but only for active server. So once they are started, only one replication object that corresponds to one active server needs to be created in standby server. So let's look at the example on the next slides. So as you look at the diagram, this is the example of creating a replication object. So this is active environment. So you create 3. So there are 4 servers, four servers. So there are 3 replication objects are created inside one server. So each active server's got 3 replication objects. Okay, because the number of replication objects is actually equal to the entire server number of entire server minus 1. Okay, so this replication object is connected to this one, is connected to this one, and this one is connected to this one. Okay, as you can see from the active standby environment, it's actually different to active. Okay, for active server only, the number of replication objects allowed in active server is equal to the entire number of servers minus 1. Okay, for the active server only. Again, the standby node, only one replication that corresponds to the replication objects that active server has. Okay. So modification is only available in an active server, so there's only one replication object in a standby node. Okay. Okay, so far I've just talked about the replication types and the formation types. Okay. And also I said the lazy type can cause replication gap as is part of nothing's features. Okay. The replication gap is occur whether is active active or active standby. Okay. However, the conflict is occur only when it's active active. Okay. Conflict means the data is not modified properly when modifying operations are executed on same data from two nodes simultaneously. When there are a lot of replication conflict, the data inconsistency can become worse. Thus, there will be problem uh, to service. Therefore, it is better not to have the replication conflicts. I'll talk about how to minimize the conflicts in later slides. The replication conflicts occur only when it is active active. Okay, only when it's active. However, it can sometimes occur on active server as well, which is quite exceptional. For example, when it's active standby, the failure has occurred from active server, so the failover is applied, so that the data was reflected in active server is not replicated to standby server. So when the failure occurred from active server while there was replication gap, then it could occur conflict by the transaction executed from the application that just fell over to standby server. Therefore, when service is not working due to the conflict, it's better to use eager type. Okay, it's better to use the eager type rather than lazy type. However, to use efficiently, the combination of lazy and active-active formation, which is without the conflict, has to be considered. Okay, Altibase provide resolution to avoid replication conflicts. However, it cannot be fully solved with the provided conflict solutions only. So it is better to consider these kind of things. Okay, now we're going to summarize all the features by combining the replication types and formation types that we have just talked about so far. First of all, the replication performance, okay, is determined depending on the replication types, okay, rather than formation types, okay. When so whether it's active active or active standby, the replication performance is fast when lazy type is used. Okay, it's fast when lazy type is used. It is same as a replication delay, the gap. The regardless of formation types, when lazy type is chosen, okay, the replication gap can could occur. Okay, like I said previously, the replication gap is absolutely normal. The problem is when it lasts way too long, the replication gap is not reduced. Okay, the load balancing is available from every node. If it's active active, the regardless of replication types. Okay, therefore the scalability and performance can be improved by load balancing. However, when it's active standby, the modification is allowed only from active node. Therefore, the full load balancing is a bit burdened. When service that requires a lot of select statement, there will be a lot of standby server that does select statement only. Okay, so the load balancing will be available and the performance will be improved. The formation types have to be considered also when writing application program. In active-active, the modification is available in every node. Therefore, there could be a lot of competition among nodes. But when it's active standby, the service role differs depending on whether the service is active node or the standby node. Therefore, it needs to write application program. Okay, for the replication conflicts, it only occurs only when it's lazy method on active-active. Okay, the conflict does not occur in active standby. The conflict does not occur on eager mode because the master transaction is confirmed when replication is confirmed as well. You would think that consistency might decrease when using replication. However, this is not because of the data conflict, which is one of the main reasons why inconsistency occurs. It is because the lazy type is used in active-active. So when operating replication, the formation type and the replication type have to be chosen depending on their service features. If the service requires fast performance, then the lazy type has to be chosen. If it's to be used for load balancing, then active-active is most ideal. Um, method. And when there's a network problem, um, the recovery plan has to be established. So even though it is on eager mode, the data consistency is not guaranteed when there's a network problem. So whether it's lazy or the eager mode, the recovery plan must be established. And just to add on the information, there are some companies that use eager type, but most of our customers use the lazy type because of the performance. Okay, and about 50% of our customers use the combination of lazy type and active active. But when this combination is used, the conflict could be occur. So we need to therefore think of ways to avoid this. Firstly, it needs to execute DML on particular table or on a particular server only. Secondly, on particular record only. Or thirdly, other conflict resolution. Okay, for the conflict resolution, we're gonna look at them on the next session, and for the rest of them, let's have a look at what those are. Okay, so now we're gonna have a look at the system design that can minimize the conflicts. Like I said before, the conflict could be occurred when lazy is used in active active. Because the modification process is available while replication gap is occurred. That's why the conflict is occurred. So the first thing we can think of is to restrict the node where modification is allowed. This method is in active active, but modification is processed only from one node, and select is executed from other node only. This will not allow any conflicts at all because the modification nodes are restricted. However, it is restricted for load balancing, meaning the load balancing for DML is not available. Therefore, the load balancing is only allowed by partially. However, when there are a lot of select operation required, you can improve the performance by incrementing the number of servers that only do select and do the load balancing. Okay. The second way is to divide a number of primary keys, the same as number of nodes. The replication process is by replication is processed by the standard of primary key value. Okay, so when a modification of primary key value is executed on both nodes, then there will be a conflict. Okay. However, to prevent this situation, it can be configured as single primary key value is to be modified only from one single node. For example, if we replicated two servers, we can divide the primary key values into odd and even numbers. Okay, odd and even numbers. So in node A, only odd primary key value is modified, and in node B, only the even primary key value is modified. For this way, there will be no modification from both nodes simultaneously, so we can reduce the conflicts. For main feature, the load balancing of all DML operation is possible, and also the caution is advised when setting up the application program. Okay, this is because we have to write the application program for odd numbers and even numbers separately. That's why we need to pay extra attention. Okay, the third way is to divide the tables. This is dividing the tables depending on the types of task. Okay, so one type of task is processed from one node only. For example, we can assign server 1 for managing table A only. Okay, and assign server 2 for managing table 2 only. Okay, extra consideration is needed when processing complex tasks, even though the load balancing of DML operation is possible. Okay, the complex task means basically, for example, when we assign each DB for modification of one table only, but all of a sudden there's a transaction that needs to handle multiple tables together, like table A and table B together from one transaction of one particular task. So we have to execute DML for table A and table B from one DB. So this kind of situation must be considered as well when dividing the table according to each task. Okay, the fourth way is using L4. The switch is used, so the same modification is not processed simultaneously from multiple nodes. This is done by identifying the IP addresses or the task types. Okay, so only the related server handle it. Therefore, this could minimize the conflict. For example, task A in business A is assigned to DB A only, and task B for business B is assigned to DB2. And all of IP addresses are saved inside L4, so L4 automatically assigns the task to DB according to the information of IP addresses and the task type. For example, IP addresses between 0 to 100 is assigned to business A, and IP addresses between 101 to 200 is assigned to business space. Okay, if we use these four methods and conflict resolution provided by Altibase, okay, it will guarantee data consistency and fast replication performance, which will prevent the conflicts even though the lazy type is used in active environment. Okay, so it was pretty much today's web seminar called the replication part 3, the system design. So we have looked at the replication types, the lazy and eager, the formation type, active, and active standby, and the pros and cons about each replication and formation type as well. And lastly, we had looked at the various types, various system design that can avoid the conflicts. Okay, I think so. I'll stop here for today. So um, hope you guys have a wonderful time, and I'll see you guys next time. Thank you, everyone.